I'm going to give an overview of what we've been up to in Program 3, which is at Spatial Infrastructures, not Spatial Data Infrastructures, but Spatial Infrastructures. Just look at this bloody thing on my down. I'll put it in my pocket. Stuff like that. But I've also got 2 3-minute PhD presentations to do as well. So that's got to be done by 1:45, so I'll crack on. Okay, so that's me, Jeff West. For my pains, I'm actually the Science Director for Program 3, which is Spatial Infrastructures. And this is what I want to talk about today is progress we've made so far, and a proposal we're doing, and then talk about what we're going to do in the seminar later. And following some suggestions from Arthur Beryl, I started to think about some questions that you should be answering when you're thinking about spatial infrastructures. Not the bad query up there, which is, give me all the data, I'll work it out for myself, which means I have to go and phone up, email, and eventually a load of hard drives turn up by FedEx if I'm dealing with big data. These are the sorts of questions I really want to answer. Who should I evacuate from the flood zone in the next 24 hours? And this is actually one that comes from a guy called Mark Wallace, who's in Queensland, and if it takes him 2 weeks to get hold of all the information he needs, in that time 2 or 3 people have drowned, not very good. Am I at risk of death or injury by purchasing this house? Because it's in a flood zone, or an earthquake zone actually, or it's a risk of fire. Which houses are unoccupied after the earthquake? Julian Carver will probably mention the way he got around trying to work that one out for Christchurch later. On the right here is an example of a query which, very simple. There was a report about fires around Sydney, so NBC in America got hold of this map from GA, showed you where all the fires are, and their headline was, Australia is on fire. Obviously, most of those fires are of no consequence whatsoever, especially all those ones up at the top end of WA where no one lives. So, very important. Okay, so they're nice natural language queries. Now, just to give you a teaser, when you start talking about things like the semantic web and that nature, you can put a query in like this, which actually comes out of a very, very recent paper, September 2013, which basically says, go to this website, pull out all the tornado events from some sensor network, and then put in a query, intersects with this URI, which basically pulls out a map of Illinois. And that will just come, you can put that into your browser, that will come back with a whole list in HTML of all the tornado events in Illinois since the time began. And you can play around. So that's the sort of stuff, that you're not expected to put that in as a human being, but that's the sort of stuff that semantic web and web processing can try and give you. Okay, so the vision for Program 3, I thought we'd have to come up with a decent vision statement for this. Seamless access to the right spatial knowledge you'll notice, not data, at the right time in the right format, and unfortunately a lot of people don't like this, but sometimes at the right price, because people like to have free stuff, but it doesn't always work. This is the sort of things we're looking at producing in this program. Intelligent search and discovery, that is the big one. Go and find me the data. Link data together, vertically and horizontal, across state boundaries and across different types of data themes. Use of orchestration of web services. Try and involve crowdsourcing, that's a big one these days. Fast and effective big data querying. If I'm talking about the last 40 years of Landsat data, which is over a petabyte, I'm not going to download that onto my little PC and try and do some querying. I want to do it remotely. And of course, that's all cloud processing as well. And something which is very big in the area is supply chain management and processing, because much data and knowledge is generated from some sort of supply chain. Okay, give you a quick idea of who owns what data and infrastructure. This is all over the place, as you can see. We've got LINS up here because we're in New Zealand, but all this other stuff, this is the alphabet department, as they call it. You can work out what that means yourself. This is all, most of this, of course, is Australian. We've got all the government departments up here, and of course, they don't talk to each other. We've got all the jurisdictions down here that don't talk to each other. We've got the Commonwealth, local authorities. We've got this wonderful thing called PSMA, which attempts to talk to all these people and produce data that people want. And we've got some standards over here. Don't forget the elephants in the room, especially Google, and of course, not forgetting the private sector, which is also supplies a lot of data, and especially here in New Zealand. So lots and lots of various places you get data, infrastructure, etc., and all, of course, you'd like to talk to each other. Okay, so some principles. I don't want data, I want results. I don't want data, I want knowledge, I want information. Leave the data where it is and run processes in situ. Use web services. Try and use standards as much as possible, as Simon mentioned a minute ago. utilise as many online sources as you've got. You've got Twitter, Facebook, all this stuff. We want possibility of sources. We don't want to go somewhere and find that, you know, we've access to web service and it disappears. So you want these things, it's just written as an official name, cool URIs, right? Or persistible URIs is another phrase for these sorts of things. Because what I want at the end is I either want a nice colour, depending on the fit for purpose, and I had to put this picture in because this is from an SGIO ad, but this is what you tend to end up with. You know, hodgepodge of bits and pieces that don't all fit together properly and you don't get what you want. So we don't want that at all. Okay, so in this research program we have some user demands, and this is worked out from last year and a half or so of talking to lots and lots of people and doing presentations. We want usability, web-based systems and automation. The areas where we're looking at in terms of research are these three here. You've got to have AI, artificial intelligence, there because you want to be doing things intelligently. It's all around what you do with the semantic web, and there's a lot of work around supply chains. Here's a number of different activities we identified that are very important. The marketplaces is less important now. These are some of the test beds. Everybody appears to be going globes. A year ago, only in Australian Northern Territory was using Google Earth Enterprise for all their data, but now we've got New South Wales as a recent one, Queensland and WA. They've all come on board using Google solutions, and just waiting for Victoria and South Australia to catch up. And then we'll have the whole of, I'm not forgetting Tasmania. We'll have the whole of Australia in Google, which would be interesting when you start putting all the data together. And there's a whole bunch of user cases or user stories that we're trying to deal with here, and then hopefully adoption at the end, of course. What am I doing? Right. Okay. We looked at exploiting current technologies. Teo Chan and Peter Woodgate did a bit of a desktop survey of some various spatial infrastructures that were around, and looked at the different levels of functionality they have. And the little box around there, a dash blue line, is showing you that they've all got various levels of search and discovery. Most of them are pretty basic and not functioning very well, especially our users tell us. So the idea is to try and use as much of these systems as possible to build on top of. Now, Simon Moncrief mentioned web services, web-based systems. It's very hard to get people to understand the whole concept of web-based systems. So we've knocked up this horrible-looking slide. But the whole idea is this is the smarts. This is the stuff that you really want to be involved in developing to really make spatial infrastructures fly. You want to be able to do fast searching, querying, data integration, visualization, all these things in here. But you don't want to grab all the data. All the data is over here. This is where loads and loads of data is down here. All the different jurisdictions. We've got crowdsourcing here, PSMA, more private sector. We've got very large data sets at the ABS and Geoscience Australia and Meteorology, all linked, in fact, to a high-performance computing system at ANU. So you don't want to have to download anything from all these people if you can help it. You want to be able to get your query such that it goes off to these places, some local orchestrated processing, there's web processing services you can run. We can run some things on a high-performance computer, etc., etc. To help along, to sort of glue all that together to a certain extent, out there on the web, as well as locally, you will have things like, in the semantic web context, ontologies, vocabularies, lots and lots of metadata, and lots of places with data, of other information as well. And internally, you may well want to store all those links somehow such that this smart software can access them. So, so that it knows where to go looking for all the various links to put stuff together and get it working. So that's, and so really, if you like, there's a lot of processing, invocation, and linking of data and information together here. Okay, there was, this is a new one actually. I've got this off the web recently. It used to be the semantic web technology stack, now it's a cake, right? Or not only a piece of cake, not a piece of cake. This really shows you all the various technologies and concepts in a three-dimensional cake here, and shows all the technologies, many of which you would already have heard of, and how they all go together. It goes right from the bottom through the formats for HTTP and Unicoding, XML formatting, RDFs, which is resource data frameworks, description frameworks, always get that wrong, up through to web ontology, web languages and schemas and things of this nature, through to logic and rules, where people tend to use things like descriptive logics, which is a form of logical rule-based system. And then you've got applications here, and of course ultimately you've got to know whether you can trust all this stuff. One of the good things about this is it shows linked data, which is implied in this slide to be a subset of really the semantic web as a concept. So, but there's a lot of work involved in linked data, and one of our colleagues from CSIRO will talk a bit about that later. There we go. Okay, so here we are at the moment. So Google's got 600 geospatial software engineers. We've got $600,000 a year. So we can't employ, because you can't do too much for $600,000, but we can try and be efficient. This project here, project 3.01, is about search and discovery and federated model, involves these people and these groups. There should be 2 PhD students here, but it's taking a bit of time to get them, unfortunately. We're going to be working with the CSIRO on some of the co-supervision of the students, because they have a lot of interest in this area, a lot of knowledge, as many of you are aware. That's actually running partially at the moment. Project 3.03 is querying big data. Managed to get this to be a joint Program 3, Program 4, which is Natural Resource Monitoring project. So there's 2 research fellows that come out of that. One's at GA, one's at QUT. That's looking at big data, and it's driven from the two researchers at QUT who are into data mining and big data, and people like GA, DEPI, which is Victoria, QDerm, and some others which I couldn't remember at the time. That's actually recruiting research fellows at the moment. This one, which is red because it's one that's just gone up for approval, hopefully. And this is all about supply chains, orchestration, crowdsourcing, licensing. And you can see that it's funding 2 PhD students at Canterbury, mainly with Femke Reismer, because there's crowdsourcing, and she's an expert on crowdsourcing, and a couple at Curtin. Okay. And there's one more down here, which is also at Canterbury, which is, I can't remember, 4.1x or 4.016 or something, code name, but it's a MSc in pharma-centric crowdsourcing. So that's running now. So we're getting there. We nearly spent all the money. Just to sort of knock through a couple of things. Search and discovery. Can Google find everything? Because everybody thinks it can. In fact, yes, if there's a paper I read that says if you put in a query, get capabilities, WMS soil Italy, it will return you about 65,000 results. Okay, and the ones you're probably looking for are probably right down the bottom of the list. So that's not very useful. We talked to people at NGIS about using a Google search appliance, which is a piece of hardware with Google search algorithm in, and you can actually put your own hooks into it to search for whatever data sets you want. And then you can do Google searches on that just using text. There's a company in WA that's managed to get it to read AutoCAD files and integrate it with the Google software. It's a piece of software called Voyager that you can put in, which will go and trawl your network and find all your files that are spatial. So you look for shape files and the like, KML files, everything, and then you can then put them into things like GeoNetwork or whatever in a catalogue. There's a thing called Swoogle. So when you're talking about the semantic web, there's semantic web Google. There's not much work been done on this for about 5-6 years now, but you can actually go and look for ontologies on the web using Swoogle. Is OpenSearch is a web page which has talks about some techniques for doing search. There's a company called ontology.com which can search for ontologies and that. And one I found out from an employee at Landgate called I got that wrong, govpond.org, right? Govpond.org. Knocked it up in 3 weeks, they said, and it will go and search across websites looking for specific types of files. And it's true to say that if you programmatically search the web, then you can get other types of files back as not just HTML or PDFs and things like that. There we go. Federated data. Now this is the danger of where people start putting things on globes. This is the Northern Territory. This is Queensland. This is the Northern Territory. This is the boundary of Northern Territory, according to Northern Territory. This is the boundary according to Queensland. This This is the road that comes right up to the boundary. This is Northern Territory, and at Queensland it sort of starts to wander off into the bush somewhere and stops. So, woe betide you if you decide to use that data to go and tarmac the road, because you'll end up with a bit missing, although that's actually a dirt road. So there's issues around federated data and to try and build seamless data sets for across national, state, local boundaries and that. And again, the CSRO guys here have been looking at that. PSMA, of course, do link the data together, etc. Okay, I think I'll stop in 20 seconds. Okay, so let me just build on a bit. In terms of supply chains, this is what we're trying to do. What you would like is the top right, which is a beautiful supply chain, very ordered way of putting data in, goes into a big data store in the middle, and there's a few customers on the right. At the bottom is courtesy of Leslie Arnold, is what happens in practice. All those... Yeah, done, mate. Yeah, good. 10 seconds, says the chair. That's what you get in practice. It's all over the bloody place. All those black arrows, and it's an anecdotal, but you know, you talk to a lot of people, you'll find they get the data from all over the place. There's total confusion out there. So we want to try and sorting all that out with all these techniques on the right. Okay, so let me go on to the end. Here we go. So roll up, roll up, roll up in a little while for a seminar. Now, what I've got is we were asked to put a seminar on because this P3 is Program 3. This is still a sort of very controversial area. We've got Julian Carver, who took us around yesterday the city and showed us and told us all about these experiences of trying to get spatial infrastructures going after the earthquake. So he'll do a talk for half an hour or so about all the interesting things he did and how the solutions they came up with, etc., etc. Then I've got Paul Box and Simon Cox from the CSIRO here. Paul Box is doing lots of work on linked data for spatial infrastructures and currently looking at a project with ANSLIC and the OSP, that's the Office of Spatial Policy, on the foundational spatial data framework. Simon is an expert around semantic web and OGC. He's been doing this for years. I remember when he told me about XML years ago, I said, oh, yeah, so what? Back in 1996, and I wasn't interested in it at the time. And then we'll have, so this will cover about an hour, and then we'll have a discussion, which will be also known, in my experience in this, it's a lively, robust debate, no doubt. But I've got all my friends and defenders with me, so it should be okay. Okay, so I'll stop there. Okay, thank you very much. Oh. Where's Jeremy? Jeremy Severinson? Quick, run.